So in this video, I wanted to show how I integrate surfaces with bodies inside of CATIA. So the first thing I'm going to cover here, the creation of surfaces. So in this case, I'm going to have what I refer to as two Solidify groups, and that means I've got a collection of surfaces, reference elements, and wireframe elements that will lead to one particular surface or one surface that I will eventually solidify into a body. So in this case, I'm going to end up with a body called disk and a body called support. So two separate bodies. Right now, I've just got the geometric sets that I'm going to utilize to accomplish this. So we'll start off with disk. So I will have a body with a solid geometry, later called disk, but right now I'm going to start off with a geometric set called disk. And under it, according to the best practices I teach, I have three subgeometric sets. I have a disk surface geometric set, which includes all of the surfaces, or eventually the final surface that would be solidified. Any reference elements, I have a disk reference elements. Then also for wireframe geometry leading for the creation of the surfaces, I will have a wireframe geometric set. So these are all nested under here. I also have an axis system specifically for what I call a Solidify group. So the Solidify group includes the geometric sets associated that will be eventually lead to a solidified surface that turns into a solid, and then an axis system as well. So you can see on the screen, I've gotten this started already. I've got my geometric sets created. I've got my primary geometric set, and I've got my secondary or subgeometric sets. And I've actually already got a point established. I'm working in millimeters. In this point, I'm going to keep this example really simple, by the way. So this point is 100 millimeters in the Y direction and negative 20 millimeters in the Z direction. And what I'm going to do is create a spline from the origin point to this point with two levels of tangent continuity, one on one point, one on the other point, and we'll end up with a third-degree curve that I will revolve into a surface. So let me accomplish that. So I'm in the generative shape design workbench already. So I'm going to go to on the wireframe toolbar, I'm going to find the spline tool. So I'm going to create a spline between that point and that point. So right now that's a first-degree curve between 2 points. I'm going to go back to the first point. I'm going to define a continuity from a curve. So from a curve, I'm going to use the curve. In this case, is going to be the y-axis of my axis system. And I'm just going to leave that at tangent continuity. So I went from a first-degree curve by adding that tangent continuity. I created a second-degree curve. You can see it's got some curvature in it. Now I'm going to do the same to the second point. And so I'm actually going to do that from curve as well. And I'm going to do it from the y-axis as well. Let's see if I can select off on that. There it is. I'm going to leave it at tangency. Now this is a third-degree curve. It started as a first, had a tangency on one end that made it a second, and then tangency on this end made it a third degree, and you can tell it has a point of inflection as well. So that's all I'm going to have as far as wireframe geometry in this Solidify group. So the next thing is a surface. Again, this is going to be simple. It's just going to be a revolve, so it won't even have operations on surfaces. So I'm going to make this to define a working location. I'm going to go to the surfaces toolbar, and I'm going to find the revolve tool. And the axis of revolution, or the profile, will be that spline. And the axis of revolution, I can either select off on the z-axis here, or I can do z-axis from the current axis system. And I want this to be a full 360. And there's my disk, if you will. So that is my disk. I'm actually through with this particular, the surfaces and the surface. This is going to be my solidified surface. So this is going to include 4 supports. So from here, I'm going to, also I need to activate my support axis system. And what I'm going to do is I'm going to create a little bit of an ellipse using the spline tool. So I want to create it out in this area. You can really almost create it anywhere you want to, but I'm going to create it out in the Y direction. So I need a reference point there. So I'm going to activate the references geometric set. I'm going to put a point in. And so notice it's coming from this axis system since it's activated. I'm going to put it at 75 millimeters and 0 in the Z. That looks good. And I'm going to create, and I'm going to change to the wireframe geometric set. Now when it comes to points, and I tell my students, usually I don't really care whether you put them in references or wireframe. In this case, I want to create 4 points. It's going to end up being an ellipse, and I'm going to put them in the wireframe geometric set. So I'm going to double tap the point tool, just for reference, change that back to 0. Now my origin point will be the point that I created before. I want to change my display to wireframe. You can also hide this surface if you wanted to get that out of the way. And in the X direction, let's go with 20. Sorry, X direction, not Y. I'm going to go with 20 millimeters. See it coming out 20. And then the other direction. It's going to be a negative 20. And then for the last two will be in the Y direction. So I'll do a 10 and a negative 10. Alright, that's enough there. So I've got some points that I can put a spline through and essentially replicate an ellipse. So go to my spline tool. It's going to be 4 points selected with a closed spline. So I'm going to close it. And I like to be, that's fairly elliptical. I can put some directional control at the points if I wanted to, but I'm going to create this pretty much a symmetrical, a true ellipse, if you will. So I'm not going to add any tangent directions for now, but that is something I can extrude. So there is essentially the profile of my support. So I can go to support surfaces, define, so I want to put my surfaces under support surface, so make that my defined working location. Go to surfaces tool, I'm going to go to extrude. I want to take this and I'm going to extrude it, and I'm going to just extrude it because I'm going to end up trimming this off later, but I'm going to extrude that just to make sure it goes all the way through. If I want to be more robust, I might do it up to a plane here, but I'll just keep it at some exaggerated dimension there. So there we go. Should have looked at that warning message to see what that meant. Double tap that again, see what it. Oh yeah, it's not a big deal. Okay, so I got that part done. So I'm going to do a little bit of a filled bottom here. So I'm still in my support surface. So I'm going to come in, I'm going to do a fill on the bottom. I'm going to do tangent support on this because I don't want a flat bottom, I want it rounded. So I'm going to go from my wireframe and then use that as tangent support. So it's a closed profile tangent support. Notice on my dialog box out showing tangent to that particular extruded surface. Do a preview. That's pretty much the effect I want. I can do more control over that if I wanted to. But if you look at my tree, what I have is I have an extrusion, I have a fill. What I need to do is join those two together so I can have one surface, actually an operation on the surface that I can solidify. So now, notice how these two went to invisible space and I've got one visible. surface, so to speak. So it's a joint of a surface, but I consider that a surface feature. So my best practice is under your surface subgeometric set is in the end you will only have one visible surface. The other ones, due to operations on surfaces, will end up being hidden. In this case, I joined two surfaces and then they became the original two became hidden. I've got one visible, and this will be the one that I end up solidifying. So again, that's best practices. What I'm going to end up doing is I'm going to end up solidifying the disc with a thickness that is different from the thickness of this particular surface. Hence the reason why I'm using Solidify Groups, or what I refer to as Solidify Groups, in order to accomplish what I want to accomplish. So I'm going to end up solidifying twice. One, I'm going to solidify this Revolve, and two, I'm going to solidify this, both into their own separate bodies. In the next video, I will show you how I integrate surfaces into bodies according to the best practices that I teach my students, at least. And I try to tell my students that these are best practices that I've come up with. Out in the real world, there's probably nobody, unless it's one of my former students, using these same best practices. So, but there are best practices that I expect my students to adhere to them. So you might be thinking to yourself, well, I could probably split and trim this and pattern it around and do more splits and trims and stuff. That's fine. And then you can solidify everything in the end, and that's fine too. But in my example, I'm going to have a different thickness for the disc than I am from the support. And I'm also going to end up doing a union trim here on my body to trim this back. So hence the reason why I'm using two different solidifies. So I'll see you in the next video.